Hi, everyone. Welcome to our webinar, The Most Misunderstood Math Standards. Thank you all for joining us today. Please check your resource widget to look at all the resources that we will be talking through today. And some introductions. My name is Nicole Bravo. I'm the project manager on the professional learning team. Joining me this evening are Jenny Beltramini. She's our math specialist. And also Rebecca Few and Brian Dean, who are both core advocates, and you'll hear from them a little bit later today. So who are core advocates? Core advocates are teachers from all over the country who believe in the potential of high quality standards and the importance of all students being prepared for college and careers. They support their colleagues in understanding and advocating for the standards and embrace the shift in instruction. And the Core Advocate Network is over 10,000 educators strong, and we'd love for you to join us if you have not already. Wondering how to join us? You can either contact Jenny, her email is there, or you can go to achievethecore.org/CA-signup, or just visit our website, achievethecore.org, and feel free to browse around for resources and tools and other webinars that we have done in the past. And now I'll turn it over to Jenny to go over the goals of the webinar.
Great, thank you, Nicole. It's so great to be here tonight. Thank you, everybody, for joining us. The goals of our webinar this evening, we have three main goals. So we'll talk about how understanding the mathematics and pedagogical implications of misunderstood standards helps teachers make great instructional decisions and support equitable instruction. And then we'll look at commonly misunderstood standards in both grades 3 through 5 and also grades 6 through 8. And we'll kind of unpack how does understanding them help teachers and students. So let's go ahead and dive in. We're going to start with the first section this evening and think about how understanding mathematics and the pedagogical implications of misunderstood standards helps teachers to make really great instructional decisions and support equitable instruction. But before we dive right in, I'd love to know a little bit about your own experiences with professional learning. So I have another poll up on the screen, and we'd love to know how much professional learning or collaboration time during the last school year, so 2018-2019, did you spend building mathematical and pedagogical content knowledge tied to grade level standards? So maybe doing mathematics in a PLC or a collaborative professional learning environment, reading the progression documents, just general learning of mathematics. So just take a guess. You could, obviously it's just a guess, but go ahead and take a minute to answer the poll, and then we'll look at the results in just a second. Great, so before we show the answers, let's just take a minute to unpack content knowledge. So an important question to consider is what content knowledge is needed to teach students a concept. And when I searched Google for a definition of content knowledge, I found that general content knowledge is what an educated person knows about a subject, like knowing how to multiply or knowing how to measure an object or a line using a ruler. However, having general content knowledge of a subject like math is not enough to know how to teach it to someone. So the content knowledge needed to teach a subject is called specialized content knowledge. And in math, that means really understanding the standards at a different level. Deborah Ball, who's done a lot of writing and research around this, says beyond being well-versed in the content of the curriculum, teachers need significant mathematical skill, perspective, and judgment. So mathematical knowledge matters for teaching, but it's not the mathematical expertise like that required in research of mathematics or for other kind of quantitative work. Instead, mathematical knowledge for teaching is a kind of complex mathematical understanding, skill, and fluency used in the work of helping others learn mathematics. And so in addition to that, in addition to specialized content knowledge, in order to teach mathematics concepts to kids, teachers also need to have pedagogical content knowledge, which is a little different. That's the integration of the math concept they're teaching and the instructional practices specific to the content. So the pedagogy needed to teach math topics, it's not generic. Inside the language of the math standards, there are pedagogical implications that teachers need to know and understand in addition to the math content itself to be able to make good instructional decisions. So let's take a look at the results. I'm actually really surprised and super happy to see that 31% of you, actually the most people on the call, spent more than 5 days or more than 40 hours during the last school year really unpacking mathematics and learning math and thinking about it. And lots of people also spent 2 to 5 days or 1 to 2 days. So it does sound like there's a good significant amount of time being spent in professional learning, just building mathematical and pedagogical content knowledge, which is super great. So we're going to give you some more ideas around that this evening and some other, hopefully, things to think about and things to consider. So let's go ahead and take a look at a 6th grade cluster heading and standard as an example. So this standard is, well, the cluster heading says apply and extend previous understandings of multiplication and division to divide fractions by fractions. And the standard says interpret and compute quotients of fractions and solve word problems involving division of fractions by fractions. So what I'd like you to consider, and go ahead and use the group chat to answer the question, what aspects of rigor does this cluster and standard call for? So is it conceptual understanding, procedural skill and fluency, or application, or a combination of those? So some of you are using the Q&A widget, which is great. I'm seeing those as well, and you can feel free to use the group chat also to answer the question. It looks like most people are saying a combination. Somebody said, I think it's all of them, a combination of those. And some people are saying conceptual and some are saying application. So I would say that those of you who said a combination of them, of all 3 of them, are correct, because the standard and the cluster call for applying and extending previous understandings of multiplication and division and interpreting quotients of fractions, also to compute quotients of fractions, and then solve word problems, which would be the application. So a question to consider is students, what is then the specialized and pedagogical content knowledge needed, and what might be misunderstood when a teacher starts teaching division of fractions, starts teaching this standard. So this anchor chart is one way that a teacher, or maybe even a curriculum, may approach teaching division of fractions. And you might reflect, after looking at it for a second, on whether or not this aligns with the language of the cluster heading in the standard, and what might have been misunderstood here. And alternately, here's another approach. So take a minute to look at this second anchor chart. And we're going to watch a small portion of an NCTM video that discusses the idea on the anchor chart further. And just so that you know, the entire video is linked in your resource widget, so you can watch it at another time.
You think about 12, and you think about 12 divided by 3, what you're really asking is how many 3s are there in 12? So if you have a fraction division problem, for instance, 1/2 divided by 1/4, really what you're asking is how many 1/4 are there in 1/2? And the answer is simple, it's 2, because you know what these fractions look like, and you can say there are 2 1/4 in a half. The answer is 2. And so it makes sense, not only from a point of view of what division means, but also it helps address the mystery of why when you divide a fraction less than 1 by a fraction less than 1, you can get a number that's bigger than either of those fractions.
Cluster heading and the standard. And some other important considerations are how will the experiences of students in these 2 classrooms be different, and what are the implications for the students and for their mathematical futures if they were in one classroom versus the other. And another really important question is, what does the difference in these 2 approaches communicate to students about our belief in their ability to understand complex mathematical concepts? And so by really understanding the intent of the cluster heading and the standard, considering the specialized and pedagogical content knowledge required to teach this topic, teachers can be sure they're making great instructional decisions and providing equitable instruction for kids. And core advocate Brian Dean, who is joining us on the webinar this evening, and who authored 3 of the most misunderstood math standards aligned blog posts, he said, during my classroom visits, I definitely have noticed some trends in instruction. There are some standards, regardless of the teacher, the school, or the district, that seem to be commonly misunderstood. Somehow the intent of these standards is lost during instruction. I don't believe this is done intentionally, but it could be a byproduct of many factors. Maybe old standards are still lingering in the current curriculum. Lessons or materials have been recycled or repurposed from before the new college and career ready standards, or maybe there's a lack of understanding of what the standards actually mean. And we know a lack of understanding of what the math standards really means happens in classrooms and in schools. Teachers are so busy planning for the day-to-day and often following the lead of the curriculum they're using, and they don't often have built-in time to read and really make sense of the standards and consider the specialized and pedagogical content knowledge required by the standards. So before we get into some specific misunderstood standards and dig into this a little bit more deeply, we want you to know that there's a blog post for each grade level, 2nd through 8th grades, around the most misunderstood math standards. And kindergarten and 1st grade are being worked on right now and will be added very soon. So the link to the entire series is in your resources widget. And we're going to go ahead and dive a little bit more deeply into some of those standards, but we hope you'll read the blog post to get the full information on all of the misunderstood standards at each grade level. So I'm going to pass off, we're going to start section 2, and we're going to dig deeply into grades 3 through 5 and some commonly misunderstood standards there. And I'm going to pass off to Rebecca Few, a core advocate, who is going to introduce herself to you all and dive in with you.
Hello, core advocates and newcomers. My name is Rebecca Few, and I'm a content lead with Instruction Partners. Prior to joining the Instruction Partners team, I worked as an instructional coach and teacher for a kindergarten through 6th grade district in Murfreesboro, Tennessee. Super excited to dive in tonight. We are going to be looking at the fraction progression within the most misunderstood standards blog for 3-5 mathematics. Together, we will unpack the concept of fraction equivalency and how we can use what we know about equivalent fractions in grades 3 and 4 to solve mathematical and contextual problems in grade 5. Before we get started, I wanted to kick us off with a quote that really resonated with me, specifically the first 2 sentences. Connections are useful because they help students see mathematics as a unified body of knowledge rather than a set of complex and disjointed concepts, procedures, and processes. Real-world context provides opportunities for students to connect what they are learning to their own environment. Let's keep that quote in mind as we dig in together. We will begin with the 3rd grade standard, explain equivalence of fractions in special cases, and compare fractions by reasoning about their size. Specifically, 3A, understand 2 fractions as equivalent if they are the same size or the same point on the number line, and 3B, recognize and generate simple equivalent fractions using a fraction model. John and Charlie's run is a great task to get our discussion about equivalent fractions going. Before we talk about instruction, what would you expect to see in terms of student work to demonstrate mastery of the previous standard, 3 NFA 3? Go ahead and take a moment to read the problem, solve the problem, and type your answer in the chat box. What would you expect to see from students to demonstrate mastery of the standard? John and Charlie's run is a great task to get our discussion going. What would we want to see in terms of student model? How could students' reasoning be elevated through their explanation? First, we want them to consider which model best represents the context of the problem. Since John and Charlie are running, a linear representation or a bar model would best represent the context. Next, we would want students to draw the model to represent the length each boy ran using same-size poles to reason and recognize that the distances are equivalent. Finally, we would want students to make conjectures about fraction equivalence, naming the fractions are equivalent if they have equal area or name the same points on the number line. That is the key. That is the understanding we want students to walk away knowing. Onward to fourth grade. In fourth grade, students extend their understanding of fraction equivalence. And then let's really look at that last part. What does it mean? With attention to how the number and size of the parts differ, even though the two fractions themselves are the same size, use this principle to recognize and generate equivalent fractions. So we have a task to help us dig into this. For part A of the task, it asks us to name the fraction the shaded part represents. B is similar, the shaded part. And then C, use the picture to explain why the two fractions above are equivalent. I'm seeing a lot in the chat box about students struggling with this standard. I agree. The fourth grade task has three parts. The answer to part A would be 3/4 of the rectangle is shaded, and part B is 9/12. But what about part C? Part C is all about the understanding we want students to have. Part C encourages students to notice the relationship between the size and number of parts in fourths and twelfths, which goes back to the standard. 3 pieces in part B, in the part B rectangle, are the same size as 1 piece in the part B rectangle, or 3 1/12 pieces have the same area as a 1/4 piece. When we make groups of 3 in the bottom rectangle, there are 3 groups of 3 shaded pieces and 4 groups of 3 in the whole rectangle. Using these groups, we can see that 9/12 is equivalent to 3/4. When students discover the numerical process of multiplying or dividing the numerator and denominator by the same number, they can understand how it connects to the identity property of multiplication. We are multiplying by 1, so the amount is the same, resulting in equivalent fractions. How did we use what we knew from third grade to answer the fourth grade problem? How did the fraction progression move to really get us to understand in fourth grade about the size of parts and pieces? I'm going to give you just a second to put that in the chat box, and then we'll answer the question together. We knew from third grade the fractions were equivalent because the shaded area for each rectangle was the same, equal area, or the same point on the number line. And as we learned in part C, students in fourth grade must take it a step farther and explain fraction equivalence by reasoning about the size and number of parts. Going back to this question for just a second, I'm wondering what a teacher would do if a student's explanation only included the third grade understanding. I wonder if a few questions would target the fourth grade concept of equivalent fractions. Here are a few I used when I taught fourth grade. I see you noticed the fractions were equivalent because they have the same area. What do you notice about the size of the parts in 9/12? How many 1/12 does it take to equal 1/4? I wonder if we could write an equation that expresses the relationship between the number of 1/12 pieces and 3/4 using what you named. Why don't you try it out? And then the hardest part for me as a teacher was walking away and letting the students grapple with the problems that I had just posed. Now moving on to 5th grade. Finally, in 5th grade, students will use what they know about equivalent fractions to solve mathematical and contextual problems that contain fractions with unlike denominators. In the 5th grade task, Alex and Justin are jogging this time. We want to know if Alex has trained enough for the day. The goal was 1 mile, and he ran 2 distances, 5/8 and 1/2 of a mile. Students may immediately dig into this problem by finding common denominators and adding the 2 fractions together, which is great. That's a perfectly acceptable path to a solution. However, what about the reasoning that can happen with this problem? This is what I wanted to see my students doing. I wanted them to be thinking and reasoning. So here students can use their 3rd and 4th grade understanding to solve the problem without having to find common denominators. They're able to use what they know about 4/8 and 1/2. They are equivalent, and when added together, they make one whole, to determine Alex will run slightly over a mile, 1/8 over to be exact. How can we push students to this solution first? I used to tell my students you have to solve without finding common denominators first. And then, of course, in the next slide, we see the common denominator solution, which is perfectly acceptable. The question I want to leave you with is which one promotes student thinking, elevates and encourages reasoning, and encourages excellent mathematical discourse. I bet you can guess which solution I believe does. Thanks for jumping into the equivalent fractions progression and for reading the most misunderstood blog post. I will now kick it over to my friend and colleague, Brian Dean.
Hello, everyone. My name is Brian Dean, and my pronouns are he, him, his. I'm also a math content lead for the nonprofit Instruction Partners, and I currently live right outside Tampa, Florida. If you're on the Twitterverse, be sure to include me in the conversation by tagging me. My handle is @FloridaMathNinja, and I would love to continue to learn with you after the webinar. So today we're going to dive into the progression within the most misunderstood standards for 6-8 math, and we'll be thinking of the implications if the instruction does not match the intent of these standards, which are all part of the major work of the grade. Specifically, we're going to hone in on 6 RP83, 7 RP82, and 8 EEB6. So let's start with 6 RP83, which reads, use ratio and rate reasoning to solve real-world and mathematical problems. Part C, find a percent of the quantity as a rate per 100, and solve problems involving finding the whole given the part in the percent. So before we dive in and talk about instruction, I just want to know, what would you expect to see in terms of student work in order to demonstrate mastery of this standard? So go ahead, take a moment to begin to solve the problem, and go ahead and type in the chat box representations you would expect to see from students. I'm going to give you about 60 seconds to do so. So thanks to everyone that's been typing things in the group chat. I've seen bar model, I've seen tape diagram, proportion, ratio tables, using ratio reasoning. And so what we're going to do is explore some of the representations called for by these standards. The first one I want to, that was called out in the chat box, is the tape diagram. It's a good starting point for students as they reason with ratios. They can see each time they create the next set of equivalent ratios, the number of questions increases by 16 and the percent increases by 20. Knowing that 100% is our whole amount for the test, we need 5 groups of 16 questions since there's 5 groups of 20% and 100. And so the 5 groups of 16 questions will give us our equivalent answer of 80 total questions on the exam. Another way to think about the problem is that students understand the concept of ratio and equivalence. Then they can reason with different equivalent ratios. In this sample of student work, the reason between sets of equivalent ratios. Notice the student started with the given ratio, 16 questions at 20%. Then they decided to half that ratio to create 8 questions to 10%. This 10% was a more useful equivalent ratio for the students. And so knowing 10% of the whole, they can easily create another equivalent ratio to get to 100%, so 80 questions being 100% in order to solve the problem. We also would expect to see a ratio table since it's explicitly called out in the standard language. Ratio tables are a nice tool to organize lists of equivalent ratios, and students can reason within that table to solve the problem. In this example of student work, they double the given ratio. So they start with the 16 questions to 20%, but then they double the 20% to get to 40%, and then double again to get to 80%. Since they're keeping track of their work in the ratio table, the student can see they have the ratios for 20% and 80%, which is their desired 100% of the exam. And so by adding the questions associated with these percents, we'll get the students to the 80 questions for 100% of the exam. The double number line, the representation that's called for by the standards, however, I've rarely seen this representation during classroom instruction. I've asked educators about the double number line, and often here it's very similar to creating a ratio table, and just with limited time to teach the curriculum, it gets glossed over. And I definitely understand that time is finite, and instructional decisions are made every day on where to spend more time and what might not get the attention it deserves. But I just want to take a quick moment to highlight the importance of the double number line to ensure it's not skipped over in grade 6. So with the double number line, this is like a crucial step to building students' understanding of graphing a proportional relationship. So when you take the double number line and you rotate the top line by 90 degrees counterclockwise, what you actually created was your XY plane. And so also those numbers that were in the ratio table and also on the double number line, those sets are ordered pairs. And so those implications of skipping this representation in grade 6 not only impacts the grade 6 teachers because it's in the standards, but also impacts grade 7 and grade 8 teachers who need to leverage this understanding to teach their grade level standards. The last example here is an appropriate connection in grade 6, an example how the standards cohere and work in service of each other. In grade 6, students are expected to be able to solve one-step equations with rational coefficients, 6 EEB7, I think part A. And so by representing 20% as its decimal equivalent and setting up an equation, it's just a great connection between the RP and EE domains, and students can solve this one-step equation by using the division property of equality. I want to circle back, and now that we went through the different representations, I want to come back to that original question. What would you expect to see in terms of student work in order to demonstrate mastery of this standard? And I want to point out 2 things that we did not see. We did not see cross products, and we did not see is over of equals percent over 100. Neither of these strategies for solving this problem help students make sense of the math, and as Phil Darrow, one of the lead writers for Common Core states, are clutter in the curriculum. They take time to teach, and more often than not, they leave out the mathematics. Solving a proportion using cross multiplication in grade 6 is actually teaching above grade level. The process is solving a 2-step equation. And then just simply teaching the trick, cross multiply and divide, is a rule that expires. Like what happens when the expression is no longer 16 over x, now it's 16 over x plus 5. And so now when that rule no longer applies. And so let's just focus on the math. And the math here will be solving a multi-step equation, which students should tackle in later grades. For those who want to explore more about why we should not teach cross-multiplication or cross-products as a strategy in grade 6, I invite you to read Kate Nowak's blog on Illustrated Math's site. So it's there for you to dive in more. Let's move on to grade 7. For grade 7, we're going to zoom in on 7RP A2, parts A and D. Part A reads, decide whether two quantities are in a proportional relationship by testing for equivalent ratios in a table or graphing on a coordinate plane and observing whether the graph is a straight line through the origin. Part D reads, explain what a point XY on the graph of a proportional relationship means in terms of the situation, with special attention to the points 0, 0, and 1R, where R is the unit rate. So I want to look at 7RP A2 Part A first. The standard gives two examples of methods for determining if a proportional relationship exists. It calls for by analyzing the pair of ratios in tables or graphs. And so note that the strategy, such as cross products, again, is not part of the standard. And so I'm going to just use an example from an open education resource, Engage New York. That could be used to meet the first part of the standard. And so in this problem, we would want students to reason with sets of ratios to determine if they're equivalent. They could compare different sets of ratios, such as 10 to 4 and 5 to 2 in the table. They also could use what they learned in grade 6 to determine the unit rate from each scenario and use that reasoning to justify if ratios are equivalent or not. And in this example, students could reason 10 ounces cost $4 or 40 cents per ounce. 5 ounces cost $2, which is also 40 cents per ounce. Students could continue to use that unit rate reasoning for the remaining ratios to determine if they also have a unit rate of 40 cents per ounce. Just a side note here, there's also a second unit rate in this scenario of 2.5 ounces per dollar, which could be useful if you had a certain amount of money and wanted to know how many ounces you could purchase for that set price. So typically, or always, you have two unit rates there. What I really like about the frozen yogurt example here is the table is provided for students to analyze. Sometimes I've seen students struggling to complete the table from a given context or expression, and before long the bell is rung. The students didn't spend much time, if any at all, deciding if two quantities were in a proportional relationship. So just keeping a spotlight on the intent of the standard will help you make instructional decisions to maximize the time students spent working on grade level standards. Similarly, in grade 7, part D, to that table example, here students spend 0 time creating the graph, and 100% of the instructional time is spent interpreting what the points 0, 0, and 1R mean in context. So knowing how to graph a proportional relationship is really important. But again, being sure to highlight the intent of the standard to maximize your instruction. So in this task, the graph is given, and so students are immediately analyzing and interpreting rather than creating. So moving on to grade 8, the end of our middle school progression here, we're going to discuss 8 EEB6, which reads, use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. Derive the equation y equals mx for a line through the origin, and the equation y equals mx plus b for a line intercepting the vertical axis at b. When thinking about the aspect of rigor to be emphasized during instruction, teachers should consider this very much a conceptual standard. In my experience in many classrooms, instructional coaching, sometimes the instruction for this standard leads to the procedure of just calculating the slope using the formula. And that just strips students of the opportunity to make sense of the meaning of slope and that strong connection to their prior work with ratios and proportions in grade 6 and 7, and also transformations in 8th grade geometry. So in this lesson from Open Up Resources, students are asked to explain why their two assigned triangles are similar. One goal of this lesson is for students to realize no matter how they construct a right triangle with a line segment on line AE as the hypotenuse, they're going to obtain that constant ratio when dividing the vertical distance by the horizontal distance. So it's after this key discovery by the students, the teacher can set the conditions for students to engage students in Math Practice 8. Look for and express regularity and repeated reasoning. Through these repeated calculations of determining the slope using similar triangles, the students will be able to make sense of the standard formula for slope and use it as an alternative method for determining slope. So before I hand it back over, I just want to reiterate that these are suggestions given here and just the start of figuring out this very complicated and challenging profession of teaching students mathematics. And I just hope our experiences in many classrooms will help grow your brain around these standards. And now that you know better, you'll do better and to ensure each student learns math at a high level. So thank you.
Great, thank you so much, Brian and Rebecca. I always learn a ton when I have a chance to think about math concepts collaboratively with colleagues. So as a reminder, you can dig in more deeply to other misunderstood standards in each grade level by visiting the Most Misunderstood Math Standards series on the Align blog. Before we wrap up, and we might actually have a little bit of time for questions from both Rebecca and Brian or myself, for us, sorry. But before we wrap up, we'd love to hear a little bit about how you might use the learning from this webinar and from the other Misunderstood Math Standards Align blog posts. So in the poll, you can actually select all that apply. What do you think you might do as a result of the webinar this evening? And of course, I didn't put an other tab, but other ideas are welcome in the group chat as well. Hopefully that was enough time for you all to consider how you might use the learning from the webinar tonight. Let's take a look at the results before we go into questions. Great, lots of people are going to do lots of things, it looks like. Looks like most people are interested in looking for more math tasks or curriculum resources to better align to standards, which is great. We know sometimes the materials we have might not match exactly the intent of the standards, and so digging into that is really important. Also, love to see that people are going to read the Align blog posts, maybe look at other grade levels that we didn't discuss tonight. We're excited that the kindergarten through second grade series is on its way on the blog as well. And hopefully you will share the webinar and it'll be available on demand after this webinar so other people can watch it and engage in the learning as well. So thank you so much for thinking about that. It looks like we do have a little bit of time for questions tonight from our presenters and our guests. So I think maybe I will kick it off. I see that you can either use the group chat, although that's a little hard for us to track because as some of you have seen, it moves so quickly. So you might use the Q&A widget to ask a question if you have one for Brian or Rebecca or me or any of the three of us. But I saw one in the group chat earlier that I saved that I think I'll go ahead and start with. And it was asked of Rebecca, but I think Brian or Rebecca or both of you could answer. The question is, are you finding that you first have to help teacher candidates or teachers relearn math and build their own conceptual understanding before they start thinking about student learning? So if you have any thoughts on that or questions about how you do this, since you both are in leadership roles, how you do this work with teachers, that would be great to hear. And I will monitor the Q&A for other questions as they come in.
Brian, I'll start and let you wrap up. That's a great question. I think the biggest thing that I've learned in working with teachers and instructional coaches and leaders is everyone needs to do the math. And that's the first part. We really need to dig into the math together and what it means to learn the concepts, because oftentimes, as we say all the time in math education, we weren't taught this way. So we do the math first, and then the second part is really thinking about that pedagogical content knowledge that Jenny discussed in the very beginning of the webinar, and so what it looks like to teach the math concepts effectively. What questions do we ask? How do we get students thinking and reasoning? And what type of math discourse do we hope to hear in the classroom?
I'll just piggyback off that, Rebecca. So thanks for starting. And when I think about, again, like Rebecca reiterated, like doing the math, and we're asking teachers, to maybe teach in a way they never learned as a student themselves. And so that's tough. And so, definitely putting in the work to build our own content knowledge for teaching by doing the math, working within our PLCs, solving problems with our peers, and through all those aligned curriculums that are out there. And so that would be my suggestion.
Great, thank you, both of you. Another question that somebody had in the Q&A is, what's your favorite resource or resources for teachers? And the nod is especially elementary teachers, but I think you could answer too, Brian, to build content knowledge. And before either of you think about resources and answering, I will go ahead and say that that myself and my colleagues at Student Achievement Partners will be releasing in the fall, probably in October, a virtual mini course around building content knowledge. We're gonna probably start with fractions and think about like the 3rd through 5th grade grade bands, but certainly it would be relevant for anybody in the elementary grades to join. So that's just one resource that's going to be coming out. And if you are a core advocate or you take the core advocate survey, you'll get notification about that mini course and the registration when it opens. But Brian and Rebecca, do you have other resources that you go to or you turn to when you're thinking about how to help teachers build content knowledge?
I think a great place to start is the open source curriculum, and then also we lean heavily on the illustrative mathematics tests that are on the IM website as places where we can dig in and do the math together and then discuss the knowledge we need for teaching students those concepts.
Yeah, and definitely what Rebecca said, needing online resources, but also I find myself going back to the progression documents. Those are like my primary, resources for understanding the standards, and not so much even my grade level standards, but again, it's the progression. So what's before and what's after. And so just becoming an expert within a grade band rather than my single course I teach.
Great, thank you. And I will, maybe I'll put it in the group chat in a second when I have a moment, but Kristen Gray, who works for Illustrative Mathematics, she and I authored an illustrative mathematics blog post around a process for helping build mathematical content knowledge, and there's some resources there, and we use both within that process, the progression documents and illustrative mathematic tasks. So I think the idea of doing math, reading the standards, and reading the progression documents is a great three-step process to help everybody build mathematical content knowledge. I think I'll ask one more question. It's a hard one. So Brian and Rebecca, you guys can think about it. But, we talked a lot about, a lot of the misunderstood math standards. The misunderstanding has to do with how to help students build conceptual understanding versus just teaching tricks or teaching procedures. And so somebody said that sometimes teachers push back when this person explains that those tricks aren't necessarily teaching students the concepts clearly and don't allow for connections to be made between concepts. And do you have any suggestions on ways to explain this to teachers who use these tips or these tricks? And I would say, just for myself, the video that's in the resources tab that I shared, just part of it from NCTM, it's around building students' conceptual understanding. That's a great video to show. We also have used at Achieve the Core a video from Phil Darrow, who talks about tips and tricks and not doing those and how those are cluttering the curriculum. So that's another great video resource. But I don't know, Brian or Rebecca, if either of you have other places that you turn to when you're helping teachers understand why it's important to build conceptual understanding.
I'll go first since Rebecca had to go first on the first two questions. So the resident teacher that doesn't see a problem with teaching tricks during their grade level or maybe proceduralizing conceptual standards. So there are the National Council of Teacher Mathematics, NCTM, has, I think Sarah Bush has a nice series of articles that talks about rules that expire. And so I think she did an elementary and a middle school one, maybe a high school one as well. But it's just really cool because it shows you like what you do in your current grade. And yes, it might get them past the test or past your grade level, but the implications for the future teacher and how and what they will have to do because that rule no longer applies in their grade level. And so that would just be, off the top of my head, a great resource to lean on.
In addition to Brian's resource, I think one of the other things that we need to do is really have an open and honest conversation about beliefs and mindset around children learning mathematics and why it's important to learn the concepts and the concepts before procedure, because most of the time teachers buy in once they really realize the benefits for students and why we need to understand math as a progression of learning, then they usually dive right in.
Great. Thank you, both of you. That definitely connects back to the original idea of the way we teach and how that communicates to students our beliefs and their abilities to understand complex math concepts. And so I think that that's really an important point. So thank you, Rebecca, for making that. Great. I am looking for the blog post to share in the group chat around building math content knowledge, and I think I've almost found it. But thank you for all your questions. We didn't have time, unfortunately, to get to all of them, but we will look at them, and if there's anything that we can personally follow up on, we will. But I think I'm going to pass it over to my colleague, Nicole, to close us out and to give you a preview of some of our upcoming webinars that we're going to have in the future. So, Nicole.
Thank you, Jenny, Rebecca, and Brian. If you found tonight's webinar helpful, we'd like to invite you to join our Core Advocate Network. We're committed to solving real problems that real teachers have, and we know the best way to do this is to know more about what folks are experiencing. As part of our national network, you will have opportunities to connect with educators across the country, maybe even the network in your state. You can keep up to date on tools and resources available on Achieve the Core, as well as a variety of virtual learning opportunities and other ways to engage with them. We also work with educators in our network to help us build tools and resources. You can join us at achievethecore.org/CA-signup. Other ways to join us are on Twitter, Facebook, and Pinterest. You can also scan the QR code in the corner there, and it will take you directly to our Core Advocate sign up. For joining us tonight, we hope that you enjoyed our webinar. Have a good evening.